Recursion.
Hello! I recently got this RCBenchmark Dynamometer, which is essentially an advanced thrust stand that is computer controlled, that has various sensors on board, such as a voltmeter, a current meter, an RPM sensor, and obviously a scale to measure the thrust itself. You can control the motor output, the ESC output. So let's say you want to do half throttle, so 1,500 microseconds. And then you can measure what the RPM is, what the thrust is, and how much current is being used. And you can output that to a file so that you can do various tests and later on do some analytics. So you don't have to have a camera pointed onto an LCD screen and sync them up to try and figure it out after the fact, which is what people used to do in the past. And what's really awesome is that this thing can be fully automated with scripting. I plan to do that. I plan to do various tests. I have a whole bunch of ideas. Some of them as basic as just measuring the throp and motor combinations. I also want to try measuring throttle response. So with this motor and this propeller combination, how long does it take for the motor to spin up from idle to full throttle? Just to see if different motors do that differently, if different propellers do that differently because they weigh more and it requires more torque. But one issue that I had with doing these tests was lipo management. And that came down to, in order for the test to be fair, you want to make sure that you're testing with large, fully charged lipos, and between each test you would charge the lipo again to make sure that this motor propeller combination, the voltage and current is the same as the first test. And that just sounded kind of brutal. And there's people that do that today, and I have tons of respect for them, but that's not something I was really interested in doing. So I recently invested, and it arrived yesterday, in a 30 volt, 50 amp power supply. So you can control the voltage inputs, and you can control the cutoff amperage if you want to, for safety reasons, for example. So if you're working on a copter that has propellers on it, you could say no more than 2 amps, which is essentially a really expensive, what are those called? Smoke stopper. Yeah, so it's a really expensive smoke stopper. But you don't have to worry about charging lipos, and you can control the voltage output exactly. So you don't have to worry about battery voltage sagging between the start and the middle and the end of a test. So it's consistent. So you know that if you say I want 18 volts for this motor prop combo, that the next test is going to be 18 volts. And it's really neat. For right now I have it set to 31.8 volts, even though it's only supposed to go to 30 volts, so I guess that's a bonus. And I have it set to 8 amps, so you can do this. Woo! And it will limit the current at 8 amps. It'll drop the voltage as well. Basically, it'll keep dropping the voltage to try and decrease the amperage. So if you were testing a motor, then you said you had 8 amps maximum, then as you increase the thrust, it would decrease the voltage, so that you can get the amps that you need at whatever voltage you want. Woo! Alright, now for testing. I'm actually going to be doing 2 tests. Well, one test that has 2 purposes. The first purpose is to maiden my new power supply. One thing I forgot to mention about the power supply is that it is designed for powering motors. I mean, not specifically for powering motors, but part of the specs, it does say that it is this is the type of power supply you want for powering DC motors. The reason is because when you stop a DC motor, especially when you have active braking, one thing you get is back EMF. You get current going back into the system. And most power supplies, that if you do that, you will fry them. I have an example. Last year, here's one power supply that I had. It's a server power supply used for charging. I decided to, without props, test my quad. So I turned it on, turned the motors to full, and then I turned the motors to 0 pretty quickly, and yeah, this doesn't work anymore. So this is designed to withstand that. The other test that I'm going to do, EngineerX who has the exact same RCBenchmark dynamometer, wanted to verify that his current sensor was accurate. And I figured that I could, with this motor prop combination, which he asked me to use, I could verify or compare the current sensor of the power supply with the current sensor of the software itself, with the sensors on the dynamometer, and see if they're roughly the same. And he could use these numbers as well to see if he's getting similar numbers or if his numbers are off. So I think I've talked enough. Now for testing. All right, so that worked very well, and it looks like the current sensors were pretty much equal. Now, one additional test that I'm doing, which I've actually done already, is measure the voltage that's coming to the dynamometer with my multimeter and compare it to what's being measured in the software. So this is 16.26, 16.27, keeps going back and forth. And in the software, you should be able to see that's 16.26. 16.26. I did do a thrust test because there was voltage drop, and it was the exact same. I'd show that to you, but I only have two hands, and yeah, I have to hold this camera, so I'm not going to do that. But you get yeah, take my word that it was the exact same. So the sensors on this thing seem to be accurate, which is awesome.